All right, so I believe this is recording. Let's take a look at these three problems. They want us to find the domain and range for each one of these equations, each one of these relations. Um, for the domain, we know the domain is the set of all real numbers, excluding, and we have two considerations, excluding any values of x that cause division by zero, and excluding any values of x that cause us to take the square root or even root of a negative number. So if we look at number 12, we don't have any square roots, but we do have a variable in a denominator. So we're concerned about x squared minus 25 if that were ever equal to 0. This factors to x plus 5 times x minus 5. And if x were allowed to equal negative 5, or if x were allowed to equal positive 5, that would give us a 0 in the denominator, and that would be undefined. So we actually have to throw these two values out of the domain. So let's draw that on a number line. Over here on the left, let's say we have negative 5, and over here on the right, positive 5. These two values are not in our domain. The other values that are not negative 5 and that are not positive 5, those are okay. Those are not going to give you a 0 in the denominator. Pick any number in the shaded region, plug it in, and do that arithmetic, and you will find a corresponding y value. So our domain is the set of all real numbers, excluding negative 5, and also excluding positive 5. So until you get used to writing that, I would suggest that when you go from your equations that you sketch it on a number line, and then from that sketch you write your answer using interval notation. Now for the range, it's a little more difficult. We're going to use the graph of this to help us excuse me, to help us find the range. So let's move on to finding the domain here in problem number 13. We don't have any variables in a denominator, so we don't have to worry about division by 0, but we do have a variable that's underneath a radical, underneath a square root. So this x squared minus 36 has to be 0 or positive. So to solve a quadratic inequality, let's first just set this equal to 0 and solve this equation. These are our critical points. And we have critical points of negative 6 and positive 6. Negative 6 and positive 6. So it's okay to take the square root of 0. So we are going to include these numbers in the domain. Now, remember that x squared minus 36 is a parabola that opens upward. And what we want is for the y coordinates of this parabola to be positive. In other words, to be above this x-axis. So we're interested in all of these x's that have corresponding y values that are above the x-axis. So our domain for this function is from negative infinity up to and including negative 6, or from positive 6 including positive 6 out to positive infinity. You pick a number like 0 that's not in the domain, and you're going to be taking the square root of a negative number, and within the set of real numbers, you can't do that. All right. To find the range, we'll do that by looking at the graph. Let's take a look at this number 14. Remember, the domain is the set of all real numbers, excluding any values that cause division by 0. Well, we've got 4 minus x in the denominator, so I know that I can't allow x to be 4 because that would give me a 0 in the denominator. And at the same time, this 4 minus x it has to be, we're taking the square root of it. So it's okay to take the square root of 0, but it's not okay to divide by it. So when you see these radicals that appear in the denominator, if it was just in the numerator, like in number 13, there was, we would have greater than or equal to. But with it being in the denominator, we have to change and make this a strict inequality, because we already said that x can't be 4, that this can't be 0. So 4 minus x has to be strictly greater than 0. So let's add x to each side. 4 has to be greater than x, which means that x is less than 4. So if I sketch that on a number line, I've got 3, 4, 5. The endpoint 4 is being excluded. We said that x couldn't equal 4. It's being excluded from the domain. And all of these values that will result in us taking the square root of a positive number, we have to pick values that are strictly less than 4 for that to happen. So our domain for this function is from negative infinity, because that left arrow is shaded, and all the way up to positive 4, excluding positive 4. So there's our domain for all three of these. Let's come in and take a look and see what the range would be. So for number 12, I've already keyed it in here on this Desmos graphing calculator. And for number 12, I see that even though there's 3 sections to this, that I can, as far as the y coordinates go, I can focus my attention here on this middle part. If you look at a table, that there's for any x that you pick and that you plug in, you're going to get a corresponding y value, and that y might be all the way down here, close to really extremely small, some extreme negative number. It could be like these values that are real close to 0, including 0 itself, or it could be some value that's extremely large, heading up towards positive infinity. So this middle portion is telling me that the range is all real numbers. So for number 12, from the graph, I can see that the range is the set of all real numbers. Now, what about the range for number 13? Let's take a look at what its graph looks like. So let's get rid of our graph of number 12. If we look here at number 13, look, it has this endpoint, this negative 6, 8. 8 is the y coordinate, and over here, positive 6, 8. So again, I see a y coordinate of 8, and all the points are above that. I don't see any point down here that has a y coordinate that's smaller than 8. So the smallest y coordinate is positive 8, including that, and then it's going all the way up to positive infinity. If you can pick x values such that you're as large a y value as you want. All right. So let's take a look then at this last one, this x cubed over the square root of 4 minus x. I'm suspecting that the output is going to be all real numbers, but let's look and see. Yes, if we start down here, we know that once you begin to look down here, well, that's just heading all the way down to negative infinity. So starting here on the left, as I come up through the graph, I'm coming from negative infinity. I'm not passing, I'm not having to jump any holes. I don't see any jumps in the graph. I'm coming up here. I'm passing through the origin, and it does look, it does look like 0, 0, that 0 is in the range. And then as I move up, I'm going up to positive infinity. So the graph is telling us that the range is all real numbers. All right, so I hope that helps, and I will talk to you later. Bye.